Greetings, aspirants. Hope you are doing well. Welcome to another video of CC concepts of the subject science and technology. And today we'll be talking about a nuclear reactor or the nuclear generator. Now, what is the main purpose of it? The main purpose of it is to harness the energy from the nuclear fuel, and the reaction which takes place inside the nuclear reactor is the controlled nuclear fission reaction. So it harnesses the energy produced from the controlled chain fission reactions. This energy is initially in the form of heat. So that heat energy is used to transform the water into the steam, and this steam is used to power a turbine from which we are going to generate the electricity through electric generator. Now it is important for the control chain reactions to occur, as it would be sun safe, because if we are not able to control it, then with the enormous amount of energy and pressure, the blast might happen, right? So it is safe for us to have a controlled chain reaction. Now moving forward, this is the picture of the nuclear generator. So this is the core reactor, also which has the moderator and the control rods. And we can say it's the reactor pressure vessel. And from here the water is pumped in, and here the water is pumped out. And this water is going to go to steam, turn it into steam, and then it's going to run the turbine. And this turbine is going to generate electric power where through this generator. Now the steam of low pressure will come back again to the water, this water tank, and from here you will be sending the coolant, and the same water is again sent back. So this is how basically a nuclear generator or the nuclear reactor works. Now, what is the purpose of these control rods? See, I told you the main thing here is you need to have a controlled fission reaction. For you to have a controlled fission reaction, you need to control the number of electrons, because with every reaction, you are going to get at least 3 neutrons. So to control the number of neutrons in this reaction, you need the control rods. So these control rods are the materials that capture the free neutrons emitted from the fission. Since the absorbed neutrons, now the neutrons which are absorbed by these control rods cannot be induced further fission reactions. They cannot be induced into further fission reactions, and the use of the control rods reduces the rate of fission. Because we are able to control the number of neutrons, free neutrons, we will be able to control the rate of fission, and hence it is essential to facilitate a controlled chain fission reaction inside the reactor. Now, while all the neutrons in an uncontrolled chain reaction are allowed to induce fission reactions, the number of neutrons allowed to do this will be dependent on the number of control rods, because that will change the number of free neutrons. The control rods are commonly made of cadmium or boron. Now, these are the control rods. You can see the picture. And these are the fuel rods which are attached in the grid pattern. From here, the coolant is going to come in, and from here, the coolant is going to go out. Now, we are going to talk about the moderator. The main purpose of the moderator is to make the reaction more efficient. Means the neutrons, free neutrons which are releasing, it will make sure that the neutron hits the other nuclei. The neutron for the fission reaction to happen again, hits the other nuclei in the right way, like either with not too slowly or not too quickly. So for a neutron to induce fission, it must first be captured. It must first be captured in the parent nuclide for temporary unstable nuclide, because this temporary unstable nuclide is going to undergo the fission. So this will undergo the fission, and the neutron can only be captured if its kinetic energy is not too low or not too high. The kinetic energies of neutrons emitted from the fission are typically way too high, so it won't be able to be captured if we carry on with the same speed. So the moderator is going to be used for the same purpose. You can see here we are going to have the fission reaction where the neutron is going to collide. Now we are going to get really fast electrons. So these fast moving neutrons are going to be moderated by the moderator nucleus, and then these slow neutrons are going to undergo the fission again. So in this way, it will help in the controlled fission reaction or making the reaction more efficient. Now, as I told you, the moderator will slow down the free neutrons produced in the fission reactions, which will be of high kinetic energy. The slowing down the neutrons increases the likelihood of successful fission reaction, which is nothing but the efficiency, and hence it increases the rate of fission. Now, these moderators are required for both uncontrolled as well as controlled chain reactions, because we need that nuclei to hit the other nuclei, right? Now, the examples of moderators include heavy water, which is nothing but the D2O, and the graphite. Okay, these are the examples of the moderators. Now moving forward, we have the fuel rods. Now these fuel rods have the nuclear fuel which we are talking about. So they are hollow rods made of metal, typically of alloy steel, and they contain the subcritical mass. What is the critical mass? Critical mass is the smallest substance of the nuclear fuel, where it will only further one fission reaction to take place. But here we are going to have the fuel at subcritical mass. This is because we are going to have various number of fuel rods in a grid pattern. So altogether that will be having the critical mass. But if you take the single fuel rod, it won't be having the critical mass. So it contains the subcritical mass of fuel or fissionable material, which is usually enriched uranium oxide or plutonium. Now they are inserted into the reactor in a grid pattern, and their combined fuel provides for the enough fissionable material for the critical mass. Then we have something called the coolant. Now this coolant is going to capture the heat. Coolant is going to capture the heat, and it will help for the fuel rods not to melt. So it will prevent the fuel rods from melting and transfers the heat to the water. Now this water that is heated at the heat exchange will turn into steam, and this will in turn help for the electricity generation via the electric generator. Now the last one we have is the shield. The shield is nothing but multiple layers of shielding is required to protect us and also make the environment safe, right? So this will multiple layers of shielding will surround the reactor for safety and efficiency reasons. A graphite shield will reflect the neutrons back into the core. Then we have a thermal shield to make sure that no temperature or the heat loss is there, because that will reduce the efficiency. Then we have a pressure vessel to isolate and contain everything inside the core. And lastly, a biological shield to protect us from the gamma rays or the nuclear radiation, which is a concrete mixed with lead pellets to absorb the gamma rays and neutrons, right? So we have discussed all the different parts of the nuclear reactor. In this video, we saw what a nuclear reactor is. Then we saw different parts and discussed the significance of various parts. We'll be back again with another video. Thank you.